Okay, we're back for part two. So in that melting point machine, when you get back to our picture, there's that little bitty bit down in there. You don't want very much in there. The more you put in there, it really will screw up your melting point. You just want a little bitty bit to melt so you can tell at what temperature it melts. Now, if you remember back to uh, phase diagram type things, here's something freezing. Here's some liquid. If you have a pure material, it should have a fixed freezing or melting point. The temperature should remain constant during the freezing or melting process, and the freezing and the melting point will be the same. So this substance, the temperature drops, gets to the melting point, freezing point in this case. So if we thought of this thing backwards, what we're going to be doing is taking the solid, heating it up. When it gets to the melting point, which you're going to determine the melting point by looking in that little magnifying glass. And as soon as you see the first crystal of the material start to melt, you start recording the temperature. Hopefully, if you have done the recrystallization process correctly, it will remain at that temperature the entire time. If you don't do it too well, or you run the melting point machine too fast, you'll get a range of temperatures. Ideally, you should have about a 1 to 3 degree range if you are heating it at the proper rate and it is pure. If it is not pure, the problem with that is if it's not pure, there's not a lot you can do about it, because whenever something is impure, the curve will look like, and I'm trying to find one here, will look more like this. You do not get a nice sharp temperature. Notice through the entire zone here, that temperature is changing. That's what you don't want, is right here. This is not good. This would be perfect right here. You just heated it up. It sat there the entire time. You went up. When the last bit of the crystal in the tube is gone, you see why you don't want very much in there. Record that temperature, and that will be your melting point range. Now, what we're going to do is we're going to put 3 different tubes in there. You're going to put in you're going to mix a sample of your material. You're just going to put some in by itself. Secondly, you're going to mix some with acetanilid. Make a little mix out of it. Put that in a tube. Then you're going to mix a third one with phenacetin and put it in there. Because if you have acetanilid and you mix acetanilid with acetanilid, you don't have a mixture, and you should see a fixed melting point. If you have acetanilid and you mix it with phenacetin, that'll make one of those bad mixes where you'll get a wide range on your melting point. Opposite would be true if you had acetanilid. Acetanilid with acetanilin, fixed. Now, the melting point on these two materials is enough difference, phenacetin 134, acetanilid 114, that you should be able to tell, when you get to 112, if it goes, you probably have acetanilid. Now, test question or a quiz. I don't know if it's a quiz question. I know it's a final exam question. What do impurities do to your melting point? They always lower the melting point and make the range of melting wider. Let me say that again. Lowers the melting point and widens the range. So let's say you got some dirty acetanilin, 114.3. Probably start melting, maybe 105, 106 if it's really dirty. And it may melt over a range of 106 to 117. Whereas if you got nice clean acetanilin crystals, we'd expect it to start melting probably around 113 or so. Simply because if you're heating, if you don't control the rate on the machine, and there's settings on the machine for the temperatures where you're headed to. And what that does is controls how fast it heats up. There are some boosts on the machine where you can punch a button and it'll boost the temperature up a little bit. Be careful with those because there's a lot of residual heat. And you say, oh, I'll boost it up to like 90. And you'll find out you let go of the boost button and daggone it, you're already at 123. So be careful with that boost button. I see a lot of people ruin their samples with that. It's very easy to watch 3 of them in there at a time, and I think they all hold like 3 or 4. So our problem's going to be obviously going to be the slower you are on this one, the probably you're going to have to wait on the machines because I'm looking at the possibility of we probably are going to have about 5 that are going to be working. So um, it is okay if you want to, and don't everyone do this, obviously. If you want to just leave, and the problem is going to be getting these things dry because wet crystals have water in them or whatever your solvent is in them. And if the solvent crystals are wet, that's an impurity, and that will lower and widen your melting point. So that's really it. You'll make your judgment on what was the unknown based upon which melting point you match up with. We've talked about the technique. We've talked about the principles. That's really all there is to this night. It's just get your stuff recrystallized and get to the melting point machines. We'll see you Thursday.